Right, let's have a look at a nucleophilic addition elimination. Easiest possible one is with water. First example in the notes is with ethanoyl chloride and water. So let's have a look at the part of the acyl chloride that we're going to attack. So we've got that carbonyl group there, an electron deficient carbon, and our nucleophile is water. So let's just present the water so the lone pairs can attack the carbon. Let's have a look at what happens next. So from the lone pair on the oxygen, attacking the carbon, and then that makes the double bond break. 2 marks for that. See if you can work out what happens next. So what have we made? So let's write down the things that haven't changed. So we've got the CH3 still bonded to the carbon, which in turn is still bonded to the chlorine. No change there. Well, we've broken the carbon double bond oxygen. That is now a single bond. That's the first thing to watch out for. What else have we got? Well, the water has formed a bond, or the oxygen has, with the carbon, but both of the hydrogens are still in place. So this looks a little bit strange and it's not quite right. See if you can work out what's wrong with it. So the red oxygen has gained an electron which becomes negatively charged, whereas the water, or the oxygen, has used a lone pair to form a bond with the carbon, effectively losing one of its own electrons, and that's now positively charged. So we didn't have a charge at the start. Overall, we still don't have a charge. We've got a minus and a plus there, so that's the intermediate. That's worth a mark. We're going to form the product now, reform the double bond. We need to lose the chlorine. It will take the electrons with it. So a curly arrow from the carbon-chlorine bond to the chlorine, and then the oxygen wants its electron back, and it will kick out one of the hydrogens as a hydrogen ion. Might not be able to see what we're making yet. Let's draw the product. So carbon double bond oxygen now. We've lost the chloride. That carbon is bonded to an OH. We've lost a hydrogen ion, and so it suddenly appears as a carboxylic acid. And there's the balanced equation. Have a go at doing butanoyl chloride. So 4 carbons in the acyl chloride. Apart from that, the mechanism will be identical. There's the reactants. Pause the video, have a go at doing the mechanism. So, we want to see the lone pair on the oxygen, arrow to the carbon, break the double bond. What will that make? Again, everything intact. We've broken the double bond. It's not quite right yet. Yep, we need a negative charge on the blue oxygen, positive charge on the red one. 3 curly arrows coming up. Lone pair reforming the double bond. Let's kick out the chloride and let the oxygen get its electron back. What is that going to make? Again, it's a carboxylic acid, this time butanoic acid, as well as HCl.